the Lanham group should be able to fix that.
We have always do the same thing, like just going back and forth to delete
Okay,
stuff.
enter. Just enter. There's a difference between cleaning the memory and cleaning the space on the device. Okay, do df minus h.
df
Enter.
minus h.
Yes, enter. Your user one is full. And already that is 10%. Okay, that's clearly the problem.
100%.
His aura data is 10%. His user one is 100%. So you don't have much backups in slash aura data.
Okay.
So you know where your problem is coming from. You know how to fix that, right?
No. We've tried.
So you were not paying attention in DB1 because we fixed that in DB1 many times. CD slash user one. Enter. CD app. No, don't put the slash. Don't put the slash. App. Enter. DU space minus sh. Space. O. Star. Enter. Wow. Certainly coming from Oracle.
I cannot recall the please, Polly.
I think someone in your group, at least one person, should be able to fix that problem.
Seriously, it keeps popping up and it's kind of like distracting because we've done it. Even I and Bello did it like a couple times, but all we just do is just go back to my
yeah, that's probably because the live location of your database are in user one instead of being in slash aura data.
Oh, okay.
That's because it's coming from the Oracle is saturated. The directory Oracle.
So I have to leave it to load up.
Yes, it's loading. Oh, it's slow. Okay. Oracle is 11 gigabyte.
Right.
So CD to Oracle. Enter. List. Okay. Do DU space minus sh again. No. DU space minus sh space all. Control C. Control C. Okay. Minus sh space all. Star key. I bet it's coming from DIAG and flash recovery area. Okay, it's coming from DIAG. So you have 5.9 gigabyte in DIAG, in your ADR, when it shouldn't be. And your flash recovery area, you have 326 megabyte, when you're supposed to actually have 0 there.
Oh, wow.
And I actually don't know why your product is only 4 gigabyte. It's supposed to be more than that. So can you CD to DIAG? Can you CD to RDBMS? Can you list? Okay, do DU space minus SH again, or wow. 5.6 gigabyte. So you clearly can see where the problem is coming from. So CD to CI DMO. Enter CD again to CI DMO uppercase. List. DU space minus SH all. Okay, it's coming from your trace file. Okay, CD trace. How can you have 5.2 gigabytes in your trace directory? Okay, list. All right. Wow, 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 wow. You see where it's coming from.
Exactly.
And I think CIDMO is supposed to be your database, your main database, right? The one you create in DB1.
Yeah.
So you still have jobs that are running. You can just shut down that database.
Oh, okay.
You must have backups running. And
So just delete it all the way from the VNC, right?
yes, from all of these, you can just do RM space all dot TRC, because it won't let you, no, star dot TRC.
Like that.
Yes. And then you do the same, RM space all dot TRM. You see, because when it's too much like that, TRM. Do it again, RMO dot TRC. When there are too many files like that, it wouldn't delete everything at once. Do that TRC.
TRC.
Yeah, do that TRC again until you're done with it. Okay, can you list it again? Can you list again? Wow, it's really, you really have a lot. You can delete everything at once. Do RM. I don't think RM would allow you to delete everything, but just do RM. Or no, just all. Just all. You see, you have too many files. It wouldn't just delete them because there are too many of them. So what you want to do is you go in your directory from on WinSCP and you delete the files. Delete 100 at a time because the RM command wouldn't delete. There are too many, way too many.
So where do I go to delete them? So I could do that. I could do that.
On WinSCP, you use WinSCP. Yes.
Why you not try the RM minus RH to force them to delete it?
What RM minus R used for?
That's what I mean. If you got the, I think, let me see.
RM minus R, it's used to remove the directories included, but here we don't have any directory included. We only have the data files. The problem here is that he has too many. The RM all command doesn't work. You can see that argument list too long. You can read the error here. It's too long.
Okay.
So I want to go to the WinSCP and just delete it or the CIDMO database from there.
No, you don't need to. Even if you drop the database.
Right.
What's your password for your database?
My password for my database. Student 81. Is that what you're saying?
What's your the password for your Oracle
Class
account?
26.
That's 26.
It's class 26, yeah.
Okay, let's see. Give me a second.
Okay.
See why you need to check your alert logs. You have to check them. You have to check your trace directory to see what's being loaded in there. I'm going to tell you how many files you have actually. You have more than 30,000. You already have 30,000. 40,000.
How come it got that much?
50,000. Actually. 60,000. Wow. 65,000. 70,000. 75,000. 96,000. Wow. 100,000. You see why the RM all load wouldn't work? 120,000.
Is it deleting, right?
It's not deleting, it's just loading actually. 130,000. It means that you never went back to your trace directory and deleted the old ones. It's like since you started DB1, you never went to delete the old files. 170,000. Wow.
Yeah, I think so. I didn't go back to the old one. I just started deleting them like just when we were rounding up for the DB1.
Yeah, the RM wouldn't work when you're past 1,000, 200,000 like that. You're past 200,000 already.
So the RM didn't work at all. It didn't even remove at all.
Yeah, both. That's why I told you to do RM only the TRC files because I knew that you might not be able to remove if you try the RM. But even the RM, that TRC, all the trace files and the TRM files wouldn't be deleted because you have, well, 270,000.
So how do I resolve this now?
You have to, actually it will take a while for you to delete it. So I wanted to do that, but clearly we can't do it. You can stop sharing your screen. Let me share my screen. You can let me share my screen.
All right. I just stopped sharing.
Okay. You have to monitor what's happening
In the
server,
server.
then you end up with stuff like that. So you tried to use RM, but it didn't go through, right?
Yes.
Before. Yeah, I get it. You can see here, right?
Right.
Not even make it full screen. Can you see?
Yeah.
400,000. I hope it's not 1 million. That would be crazy. So it means that you must be having a lot of errors in your main database. That's why it produced so many trace files. You need to shut down that database because it's not like you'll be using it.
Yeah. So I need to drop it.
You can drop it if you want as well. 500,000. In the meantime, Samuel, I hope that you're getting ready for the assignment.
Sorry?
I said, I hope you're getting ready for the assignment. You know that you'll be doing it, right?
Oh, I'm not aware of that.
Really?
I'm not aware that I will be doing it. But I don't know. Because by this time it has been messing up, so that's why I've not been able to.
Okay, I need someone else. Okay, we need someone else. We don't want to deal with messed up database right now.
Exactly.
I can do it.
Okay, Anita will do it. 600. Wow. This is incredible. But you should be able to delete everything with
RM?
No, with WinSCPU, even with SQL Developer. But with PuTTY, it won't let you. The RM command won't let you. It's too many.
Wow.
Honestly, if it's past 50,000, you have to do it because it will take too much time. But you can see that it's almost at 700,000.
Yeah.
Yeah.
Yeah, I could do it after the class. I could just take my time since like.
Yeah, you take your time. You can't remove 1,000 at a time. That's really
Where do I go on the WinSCP though? The trace files?
Yes, you see the path right here.
Yes. Oh, okay.
I think it's the first time I see that. Like, it's wow. This is just incredible.
I guess because I didn't delete any.
Since DB1, you never even maybe try to fix the issues that your database had, because if it produced so many trace files, it means that you see it like 800,000.
I guess it's going to be 1 million.
Cameras,
Yes.
this was the problem I've shared to you on WhatsApp.
What is it?
I know I'm talking about this one that they teach you this problem.
Oh, that one? Oh yeah,
Yes.
that's actually unusual. I'm not gonna lie, that's unusual.
Yeah.
Yeah. So the RM comment failed. The RM TRC, wow. So that's what you do. But in case the RM comment fails and you try at least the old dot TRC or old dot TRM. Usually it works, but this is a very unusual case.
But finally.
Okay, how much was it? How many of them?
I think it's about 900 and something.
Yeah, over 900,000 files. Wow. That actually makes me curious. What's the maximum that the RM can delete? Okay, let me try something. Because this is like too long. No, I didn't put your student number. Let me try something. I'm not sure it's gonna work. Let me see. Wait, seems like my server might be slow. Not sure why. Okay. Wow. You see how much you have? How many you have? 5 million.
5 million?
You can read it for yourself, right? 5,369,000.
So it actually stopped responding because it was too much. Like, I mean, on the Windows
On
CPU.
Puri. Wow, so you cannot do that on Puri. You cannot do that on. Wow. Well, that's actually something to fix. The first time I see it, 5,000. But there must be a way though. There must be a way to bypass the limit.
Oh, okay. Is the network slow or what?
No, it's not the network. It's just you have too many things. I just found something. I'm gonna try it. Honestly, I've never came across that, to be honest. A directory with 5,000 file. Wow. Let me see if it works. Let me just copy in case it works, because clearly we won't have it again. I need to open a notepad so I can share it with the morning class as well. Okay, considering the fact that you have 5 million files, let's just move. I'm sorry, but let's just move on with Anita so she can start doing it, and I'll let you know if it worked. Okay?
All right, no problem. Thank you.
I thought you want to fix my issue, or I should hold on.
What's your issue?
Oh, I thought that was what you called me for. The
No. I called you to do the assignment.
Oh, I'm still having that issue. I don't know. How do I resolve it though?
What issue?
The what do you call it? When I'm trying to go to my SQL, is asking me for username and password.
Oh, I told you to change your password file, right?
Yeah, but I don't even know how to go around to do that.
Okay, let's list then. Okay, it's done. Now you have extra directories. Now you're good.
Oh, so that worked.
That worked. Actually, I've learned something today, and I'll share it with you guys.
So
That comment. Even if you have 5 million files, it will allow you
To delete them.
Yes.
Good.
And now you're down to 66%. Wow. Okay. So I want to stop sharing. Anita, you can share your screen.
okay.
Thank you very much, Emma. I appreciate it.
Welcome.
Are you gonna fix Samuel's problem?
Excuse me?
Are you gonna fix Samuel's problem?
We talked about Samuel's problem last time. He needs to change his password file.
So how do I do it though?
Okay, you said that it was the same for all of your databases, right?
Yes.
Okay, share your screen.
Okay.
Okay, actually, let me share my screen because so we won't waste as much time. Let me share my screen. Actually, no, you should do it. I'm gonna let you do it. Share your screen. Share your screen. So you will know how to do it. Okay, you want to first go to CD, go to DBS, Oracle Home/DBS.
Okay. That's CD, right?
Yes. Oracle Home/DBS. And you remove all the password file because they are not, none of them are good.
So what am I removing?
Okay, I think it's better if you do it on WinSCP. Can you do it on WinSCP?
my WinSCP.
Yes. Can you do it in WinSCP? So you can delete all the files starting with Aura PW.
No, where do I go to?
If you don't know where WinSCP is.
No, I'm on WinSCP right now.
Okay, we cannot see it. Can you share your whole
Oh.
screen?
Oh, my bad. What's going on? I don't see it. So many more.
Just stop sharing first, and then you have to share the first screen on your top left.
It's not even coming up. That's the thing.
If you move your mouse, it's gonna be on the right on top of your screen. It's gonna say stop share.
Oh, yeah, I've seen it. Can you see my WinSCP now?
Yes.
Yes.
Okay. Thank you, Anita.
User is on view 01. Yeah, down the second to the last one.
The second to the last one, yeah?
Yeah, down.
Yeah.
Okay. Can you connect to one of your database, CLSDMO?
TLS demo on UNSCP?
Yes.
Uh,
Leave it open, leave that part open. And can you connect? Yes. Connect to
regular
SQL.
SQL?
Yes. SQL plus spaces / Brontek1 as sysdba.
So it's 6, right? That's
Yes,
fine.
/ Brontek1 as sysdba. As sysdba. You clearly can connect. It's just that you cannot connect with the /. So show parameter password. Show parameter password. Enter. Okay. Remote logging password file string exclusive. Okay, so you're good. Go back to WinSCP. Remove all the password files that you have there.
That's this one?
All of them. You said that they're all bad, right?
Yes. What am I doing? Delete there?
Right. Okay. Go back to Puri. Shut down your database. Okay, exit. Okay, Aura PWD.
Aura.
Yeah, Aura PWD. Yeah, space, file, equals. Actually, delete everything. Enter PWD. Remove everything.
Should I remove the file?
No, remove what you just wrote.
Oh, okay.
PWD. Enter. Okay. Aura PWD. Space, file, equals. Now copy /user1 all the way to DBS. Copy what you just. Can you copy the whole thing? Paste. Now put / Aura PW TLSDMO. It's TLSDMO, right? No, TLSDMO is uppercase.
TLS.
TLS.
Oh, sorry about TLS.
LSDMO. Space. Password.
Password?
Yeah,
Like
password.
full spelling password?
Yes. Password equals Brontech1. Space. Entries equals 10.
Entries?
Yes, entries, IES equals 10.
It was same.
10, no. Not same, 1 0.
But as a full 10?
1 0, remember. Okay, enter. Okay, now go back to WinSCP and refresh to see if it was created.
Yeah, okay.
Okay, it was created. Now connect back to SQL. First, try to connect with SQL plus C/Brontech1 as CDB, and then just connect with the slash.
Emerald, please, I have a question. So here, why did you not touch to create the file?
No, because that's how you create a password file.
Oh, okay, so it's different.
Yeah, it's binary. Okay, SQL plus space sys. No, space sys/Brontech1 space as sysdba. Okay, you can connect, exit. Now do SQL plus slash as sysdba.
SQL plus.
Yeah. SQL plus slash space as sysdba. Let's see if it works. Insufficient privilege. And that's the error you had before, right?
Yes, sir.
So it has nothing to do with your password file, but it's the privilege. Okay, I think let's come back to it later. because one of the thing was to change. Okay, can you go back to your WinSCP? I want to see something. Can you open the P file for that database? Okay, can you first create SP file from P file on PuTTY? Create SP file from, create SP file from P file.
So I should just enter the password.
Just enter, and enter. Okay, and now connect with sysdba. Just do SQL plus sys/runtech1 as sysdb again. And you create SP file, you create P file from SP file. You must, there is a change that was made.
What do you want me to do now?
Startup, create P file from SP file. Can you create P file from SP file? I hope you didn't revoke. No, I don't think you would do that. Yeah, that's what it means. But I don't know how you would do that. Okay, create P file from SP file, semicolon. And, okay, can you open your P file? No, you're already in the right directory.
Oh, for the TLS anymore.
Yes, init TLS demo.
P file. So you have to refresh.
No, P file. Okay, init TLS demo.ora. Can you open it? I'm looking for remote login password exclusive. So that one is good. Okay, can you go back to PuTTY? Can you grant sysdba to sys? That's just crazy, but can you grant sysdba to sys? Oracle not available. Oh, startup. Can you start up, please? Startup. The thing is, it's the sysdba privilege that allows you to do it. So grant sysdba to sys. Can you do that? Grant sysdba to sys. Semicolon. Grant succeeded. Okay, exit and try to connect again. Exit and try to SQL plus / as sysdba. No, sysdba. No, you didn't put sysdba. Insufficient privilege. Okay, can you grant sysdba to another user? So can you exit? I think the might, like, I wish I knew what you did with sys. So can you grant that privilege to another user? So connect back as sys. So SQL plus sys/. Okay, can you grant sysdba? I know that's crazy. To HR. I just want to see if it's going to work. You can revoke it later. Exit and try to do it again. SQL plus / as sysdba. It's still the same. And you're connected as Oracle. Okay. I think I'm going to have to look into it because I think the password file was the issue, but it's not the username. It's not the password is exclusive. So it has to do something else. So, but it's already 7. So we'll come back to it at the end of the class. I think it's better. So Anita, can you please connect to do the assignment?
All right.
So question 9, you had question. Okay, yeah, there was something that. Okay, can you show question 9?
Yes.
Question 9. Okay. In 9A, right? When we wanted to see, actually, in your table, because you made so many changes, we were not able to view. But there are actually 2 users. We did this morning. There are 2 users whose 4th letter start with is A, and the last letter of the last name end with S. There are actually 2 users.
Okay.
So if you can do that, start with that one, and then we will just do the other 3 questions.
Well, then it has to be like different letters because I already did it. I already deleted them because I already did that question.
Yes, that's why you will create another table, another copy of the table.
Of which table? Oh, of HR?
Yeah.
Of employees. Okay. Why am I into this here? Okay, so what should I name it?
You want it to be owned by sis?
Sis?
No, make it demo that employee or EMP.
Oh, should we do it in demo?
Yeah. Connect as demo. I mean,
I
not
guess
as.
I can still do it in demo because I did those in QAT and prod, right? So do I still have to create the table?
Yeah, create a table.
Okay. In demo?
Yeah.
Demo.
EMP. It's fine.
EMP.
As select all.
Okay. So what am I doing? First, I want to view all those employees. Okay. All right.
Our first name like underscore. Percentage. Comma. What do you put comma?
Oh, yeah.
Emerald.
Yes.
I think the table she's creating, she had to create a table as employees or employees.
She already did the assignment, so she's creating a different table.
A different demo.emp.
Yeah, she's creating a different table because she already did the assignment.
We had demos.employees, so this one is EMP.
I'm talking about the select all from HR.employees.
No, it's select all from EMP. That's the copy of the HR employees.
This one, you're talking about this one? Or what I'm writing right now?
No, I'm talking about the first one. But
Yes.
I thought we created a table demo.employees. Because when you try to delete, you're deleting from employees and not HR.em anyway.
No, I'm deleting from EMP. Because I created the table called EMP, so I'm going to be deleting. So I got everything from HR.employees and I brought it to EMP. And then now I'm going to be deleting from EMP.
Okay.
That's underscore name. All right, so now I'm just trying to see all those. So we have 2 people.
Okay.
All right, so I want to delete.
Delete from
EMP where okay. All right, so here I want to see if it's deleted. All right. Okay, so part 2, update all the numbers starting with 515. Okay. From this same table, right? Mm-hmm. Okay, so
Number is the paid
No.
number with commas, not with a string.
I cannot see the bottom of your screen. Can you
Anita,
bring it up?
just clear your screen and you type it.
Huh?
I say you can just clear your screen.
Clear.
No, Anita, I think the error is after phone number there is a comma. In the parentheses, after phone number there is a comma.
Okay. All right, so I don't know how to check. So. All right, so B, create a table LM. Okay. All right, so I already granted all the privileges to dev and prod. So should I do it in QAT and prod and demo?
You can just do it in one database.
Okay.
In one as one schema.
So I'm in demo. Actually,
You can do that in demo. Create a table OLEMP in dev.
in
If
dev.
you already did it, then just do it in demo.
In demo. Okay. So I have to exit. Why did I exit? All right, so
Anita, you need to connect as demo, right?
first I have to grant him demo the privilege to select on Scott, on HR, and on OE.
Right. To select and update.
Yeah, okay. You know what? I'm just gonna exit. Okay, so do I really have to grant the privilege to update to? Why do I have to grant the privilege to
Which
update?
question is that? 10?
No,
Oh, no.
9B.
Okay. Give the privilege to update for question 10.
Okay.
For question 9B, you don't need to just select.
Well, here, do I have to do it as a user? Can I just do it as sys for B, for 10? Because it doesn't say as who.
Yes. You're not expected to do anything as sys though.
Okay, that's fine. So grant. So I'm doing it as demo. I need to do something else. Create. Okay.
Here, please, can you mute?
Who needs to be muted here? No.
Okay. All right, so I have a confession to make. When I was trying to do question 10, I messed up and I think I updated the wrong columns. So is it possible to like update for different employees here?
Okay. Actually, you can just use demo.emp, right? That's why we created a new one.
Oh, okay, yeah, as a subquery. Okay. All right. All right. So...
Did you do question 9?
Yes.
9B?
Yes.
I'm not seeing all the last name listed.
Oh, you want to see the last names? Okay.
The last name, the first name, and the e-names. I want to see all the names displayed. So select last underscore name, first underscore name, e-name from the table. No, last underscore name,
select
first underscore
last
name.
name or employees. Okay.
Huh?
No, keep going, it's okay.
And then e-name.
Yeah. Okay, so you have all the first names and all the names listed basically. And you could give it an alias, for example. For the first one, you could have put e-name for Scott or a first name for OE or employees. But that's fine. I'm sure you guys know how to create aliases. So let's move on to question 10.
Okay, I have a question here. So how do you differentiate which table they're coming from?
The table, not the table. What do you name it? This OE.employees is a synonym of the table HR.employees. So they both have the same data. Yeah. We'll talk about it when we start chapter 4.
And then, like, how about Scott?
For Scott, it's e-name. You have the employee name. You only have one column for them.
Oh, okay, cool.
So e-name is for Scott table, and last name and first name is for employees table. HR, not employees.
All right, so question 10.
Emmy, I have a question. The joints, are we gonna do it as a class or we not gonna do it?
Do what?
Join.
Do what?
Joints.
She just did it, right? When she created it.
No, I mean, like for example, the other types of joins, how do we use it?
Okay, we'll do that next time. Next class, we'll mention it.
Okay.
You have a chapter to finish.
Well, I think we need to grant because we're using that table.
Yeah.
Yeah, I didn't need to. I don't need to grant. Okay, so what I have is so we are updating. We're updating this one. Which one?
Yes.
Okay. So select. So what am I gonna need to see? I'm gonna need to see the
Phone number.
and the last name.
Select last name, first name, phone number.
Okay. First
Because two
name.
people can have the same last name. Employee underscore ID.
ID, phone number.
It's a
Anita
title.
from.
No, you're not supposed to use OLM. You're not supposed to use
We're not
OLM for
using
that.
all
You're supposed to use.
or the EMP.
No, you want to use.
EMP,
Yeah,
right?
use EMP.
Okay.
Yes.
You can use our last
Where
name.
last name, yeah.
Yeah. Doran. I think it's O.
Dora, oh yeah. Thank you.
It's case sensitive, remember.
Okay. Yeah, so this is what I was saying, that I messed up.
Okay, you have
Yeah,
two Doran.
so yeah, because I messed up with my my HR, so that's why he just copied the wrong thing.
Okay, at least you can have the employee ID, which is 160 for Louis Doran.
Mm-hmm. So that
You don't
means
need
this, because like this is what I did. I changed, instead of changing for her, I changed for him.
Yeah.
So that's why I was wondering if we could work with 2 other people.
Oh, Wins. Okay. Okay.
Yeah, updated
Use the
his last
opposite.
name and his phone number.
Okay.
But do you want to set off from EMP?
Yeah. Check. Use another one. You have it.
Okay.
You have to use another one.
Okay.
You just select last name, first name, employee. You can just copy what you just wrote, except that you remove where. You remove the where clause from EMP.
Okay. So should we work with these 2? Wash and
Fini. Okay.
okay.
No, they have similar phone numbers. I want to see the difference between the 2 phone numbers. So let's use Johnson Charles and
What is
Bell Sarah.
this one?
Use that one. And the other one would be
Sullivan?
yeah. Or use Abel Ellen. Okay.
Alrighty. All right. So we're trying to update the last names. So update EMP set last name. Because select name from so what I want to change his name, right?
Right. It's better if you write what you're doing on a notepad so that we can see the sequence statement if you make a mistake.
Okay. All right, so all right, so update. So I'm changing this guy's name. 1 second.
You're changing the guy's name or the female's name?
Who is the female? Oh, she's a female. Okay, so I'm changing her name.
Right. To match the name of
So I have to put
John's
his number
event.
first, yeah.
Right.
Oops. Five, and then
Anita, you need to put a number inside the strings.
do I really?
No,
Okay.
she doesn't have to. It's a number.
I don't think so. Okay. Where underscore ID goes.
Equals 180.
Mhm. Where goes to 7. All right, so what do I want to select?
Select first name, last name,
Yeah.
employee ID.
Okay, never mind. Select first underscore name, last name.
Employee underscore ID.
19.
Where last underscore name, like.
You have to put like. Can I not just?
No, you don't have to. You can just put equal. What's his last name? They're supposed to have the same last name now. So.
Yeah, so she's supposed to have Jones. Jones.
Right. I forgot equal. Strings.
It's sensitive.
Thanks. Okay.
Okay.
So
Yeah.
All right. So the other one is equals.
There is a typo.
Yeah, thank you. Mhm. Okay. Is it though? Why? Oh, it did work. Okay. Emerald.
Yes, it worked.
Hello.
Okay, so
Yes.
yes, it worked.
Okay.
Okay, so let's take a 20-minute break, just 20 minutes, and let's come back in 20 minutes. We'll start chapter 4.
Okay.
Right?
Yeah.
4. Using DDL statements to create and manage tables. Objectives. After completing this lesson, you should be able to do the following: categorize the main database objects, review the table structure, list the data types that are available for columns, and create a simple table. Explain how constraints are created at the time of table creation. Describe how schema objects work. Objectives. In this lesson, you are introduced to the data definition language, DDL statements. You are taught the basic of how to create simple tables. Okay, you already know that. Database objects, naming rules. Okay. What are some of the database objects that you know?
Tables.
Yes, tables.
Data files.
No.
Schemas.
No.
Please, what was the question?
My question was, what are some of the database objects that you know?
Is there an example of object database?
That you know, yes.
We have indices, we have tables.
Why we say, right, indexes, right?
Yes.
Table. Schema is a collection of objects, so it's not an object in itself.
Right.
Right, okay.
Emma, does that mean that database link to the database object?
And data files are physical. They are not database objects. What did you say?
I mean, does that mean that database links are database objects?
Yes, database links are objects.
Okay.
Logical objects.
What about the view?
Right, view is an object, right.
Still logical.
Right. What else?
Sequence.
What's a sequence?
The sequence is language.
A sequence is a language?
No,
Sequence, not SQL.
He said
Value.
sequence, no?
Sequence is a database object.
They are numeric values.
And what is it? What is it?
They are numeric values.
What is it used for? Can you give an example?
Overcast full.
Okay, we will use the example right now, don't worry. Okay, so the database object that we have, those are some of the database objects. So these ones you guys should know. Everybody should know at least those. Table, views, sequence, indexes, and synonyms, right? Another thing, if you want to view the object, let's go to SQL Developer. You can see here, right? This is for database. You can see that here, all of them are objects. You have tables. You guys see? Tables, views, indexes, packages, and in the packages you have, okay, I'm not connected. Okay, in the packages you have body packages, bodies, you have procedures. Okay, I'm not connected. Okay, whatever. You have procedures, you have functions, you have operators, you have queues, you have queues table, you have triggers, types, sequences, you have materialized views, you have synonyms, right? You have public synonym and you have database links. So there you have all the objects and you have directories.
Okay.
Logical,
Okay.
right? Not physical. You can have logical directories such as data pump, right? Logical directories that is mapped to a physical directory, but it's logical. This one is not connected.
So I have a question. So the files inside the directories, do those also count?
No. That's why I'm saying it's not a physical directory, logical directory, right?
So there are no files in there?
No, it's logical. It's mapped to a physical directory, and a physical directory is the one that contains physical files.
Okay.
Right? Okay. Like the DRPAM would be the logical directory, right? The directory object.
Okay, yeah.
But /data/pump or pump whatever would be the physical directory mapped to the logical one. Okay. So there we have our objects. So if you want to just practice, you can go that. Those are questions that I heard that it might be an interview question. What are the database objects that you know and that you've used and that you're familiar with? So at least these ones, at least, right?
Can you explain synonyms a little bit?
I'm going to explain each one of them.
Okay.
Actually. Okay, table, we all know a table, right? Composed of rows and columns. Views logically represent subset of data from one or more table. Give me an example of a view that you know, that we've seen in DB1.
$V instance.
Right. What's $V instance? What kind of view is it? What type of view is it?
Dynamic.
Right. Dynamic performance view, right?
Yes.
What's the difference between a dynamic performance view and the other one?
Oh, jeez.
Okay, what's the other type of view first? It's not just for you though, it's for everyone.
Yeah, there is dynamic performance and there is oh my gosh, that was so last century.
You guys know that you should not forget DB1. You guys know that DB1 is actually going to help you a lot for your interviews to get the job. And project would basically help you build scenarios that you will talk about for your interview, right? Things that you would claim to have done at work. But DB2 is what will keep you your job. Like if you do DB2 well, it's very unlikely that you will lose your job. So getting a job is not hard, but it's good to get the job first, right? And when you get the job, some people get jobs, even people who were here, they got jobs, and after 2 months they were fired, they had to move to another state because they couldn't, right? That's because they didn't do DB2 too well. So the way Prof did it was actually really, really good. So every single class is important. Don't underestimate DB1 because you left DB1, right? DB2 is important too, and project is important too. So all of them are equally, to me, they're all equally important. Because what's the point to have a job if you lose it after 1 month, right? So always go back to your DB1 notes. I still go back to my DB1 notes if I feel like I forgot something. So go back to your DB1 notes always. So we have dynamic performance view, right? The dynamic performance view, you can see them, you can have access to them when your database is not open, right? When your database is mounted, or even just when the instance is just started, right?
Yes.
And you have data dictionary views.
Okay.
Now, for data dictionary views, what are data dictionary views? What kind of information does it contain? Do they contain?
They are the central part of the data.
They are?
The central part of data.
What does that mean?
That means they
What does it mean? Data dictionary, where do we get the information, right? When we query for a specific view. It's actually, we get it from the data dictionary, right?
Yeah.
And where are data dictionary information stored?
In views?
No. We have access to the information through the views, right? But where are they stored? You guys forgot already. Base table. They're stored in base tables.
You're stored in what?
Base tables.
Oh, base tables.
Yes. And base tables are owned by
Oracle.
System.
Oh, system.
Or CSOX. Yeah. So it's good to refresh our mind with DB1s because it's not going anywhere. It's not going anywhere. Okay, so for the views, I think I gave the morning class an example with views, but I can't remember. I can't remember, sorry. If it comes back, I'll let you know. Okay, sequence, generate numeric values. Okay, let's get an example for sequence, right? I'm going to explain what sequence is so that it will never leave you. Okay, restart. Okay, Anita, the question you had last time was actually a really good question because it's going to be explained. I keep putting the wrong password. It's going to be explained here, even in more details. So did you guys notice that, okay, let me connect to HTML. Okay, I need the student ID of the student that had an issue with his. Of the student that had an issue with
Samuel.
Student 81.
No, not 81. The other one that had an issue with that couldn't use the slash to connect.
Okay.
What's wrong with your? You cannot connect to SQL.
Hello?
Check. I cannot connect to student 81. Supposed to be able to connect. That's wrong.
Spacing.
Okay, that student that had an issue that couldn't use the slash to connect. The password would say.
That
Who
wasn't
was
me.
that? No, it
I
wasn't
think
student
it
81. It was
was
another student. I said that we would
It
deal
was
with it.
Samuel.
It was Samuel.
Yes.
Okay, Samuel. What's your student ID, please?
310.
310. Okay, we work on that. 310. I'll work on that. If you don't have time at the end of the class, I will.
Okay, all right. Thank you.
I'll let you know. Okay. Okay, so you guys remember that. Okay, let's create a table. Let's create a user in a table. Let's quickly try to do that. Actually, we kind of have time, but still. Okay, let's quickly create a user. Create user test. Let me just grant DBA to test. This is just for practice. You should not grant DBA, right? To any user like that. Okay. Let me connect as test now. Connect to test as test. Create table, employees as select all from HR.employees. Table created, right?
Right.
And I can duplicate it, right?
Right.
Right? Insert into employees as select all from HR. Not, there's no as. Select all from HR.employees. And I can do the same until infinity, right?
Right.
It's the same. Now, if I connect to it as HR, okay, that's probably not the password for HR. Okay, and I try to insert into HR. Let's see what it says. Unique constraint, email UK violated, right? You cannot insert into HR. But let's connect back as sys. Oh, system. And let's describe HR.employees, right? And let's describe test.employees. We can see that the structure is the same, right?
Right.
The table structure is the same. There's no difference. Apparently, the same, right? Okay, the structure is the same. And the data we have inside is the same as well. If we select all from test.employees, you can see that it's the same, right? We have 535 because we triplicated or for coincident, whatever, right? We multiplied it by, I think 5 or 6, no 5. Okay. So you can see that the structure is identical, the data is identical, but so what's going on, right? Why can't we duplicate the table HR? right? Okay. Now, I want to drop that test, that employees again. I just wanted to give you that example. There's that employees. Drop table. Test that. Who just have truncated it, right? You didn't have to drop it. It's okay. Let me recreate it. Create table. Test that. Employees as select all.
Can't you go back?
Roll back.
Yeah, like if you go back.
Can you roll back after
No.
dropping?
No, you have to flashback.
Flashback. I
Yeah.
thought flashback is the view.
Flashback is a view.
Flashback is for DDL.
No, like to view, like to view what you just did.
We'll do flashback in chapter 8. No worries. You don't understand flashback clearly, but we'll do that. Don't worry.
Flashback, okay.
But flashback is not to view. Flashback is to go back in time, get data from a point in time. Okay. So create table test as select all. So we have our table back. So when we select all test that employees, order by employee underscore ID, set line size. Okay, I need to set the column right. First is 13. There's another one that I wanted to use. Department ID. Yeah, department ID. It's okay. Employee ID, first name, last name, email. I don't want a table to look like that. Okay. Okay, let me just leave it like that. I wanted to use department ID, but okay. So you can see that here for the employee ID, this is the employee ID that we have here. Actually, I don't like the way it looks on them. Let me see how many we have. 1, 2, 6, 9, 10, 11. Okay, that's better. Okay, so you can see that, did I use order by? I didn't. Test that employees, order by employee underscore ID. Okay, so we have it start from 100, right? And it goes all the way down to 206, right? So what do we use the sequence for? Basically, sequence are integers. Basically, it allows you to add additional values to a specific table. Right? It generates numeric values each time. So let's look at that table. You see we have 183, 184, 185, blah, 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 goes all the way down to 206. So for example, if you're not looking at the table and you just want to add new employees to the company, for example, instead of going back and check which employee it is, right? By just using the sequence number, you would be able to know, you would be able to use it. Like you'd be able to use the sequence and it will automatically update. So I'm going to, okay, let's create a sequence. Better. Let's create a sequence and let's name it sequence 1. Okay, considering the fact that we see that here it's from 100 to 206, we want to start with 206. So it will start reading from 207, 208, 209, 201, right? So we start with 200, right? Increment by 1. Increment by 1 means that here you can see that we go from 190 to 191, from 191 to 192, from 192 to 193. So increment by 1 is that it goes up 1 at a time, one numerical value at a time. You guys notice that in some tables like regions, you have 10, 20, 30, 40, 50, right? So that one would be increment by 10 rather than 1.
Okay.
Okay. And then you can specify max value that you want it to be. Max value can be 1,000. Max value can be 1,000. And then you have 2 options. You can have cycle or no cycle. Cycle means that it goes back to 1, right? When you add values, it goes back to 1. But this is a primary case, so there's no point in using cycle here because if it goes back to 207, it will give you an error, right? Constraint error. So for that specific one, no cycle would be the best option, right? Okay, sequence 1 is created. Now let's use it so that we can see the example. Okay. Right. Let's insert into HR, no, test that employees values. First one is sequence 1. The second one would be, okay, actually, let me just get inspired by one of these. Okay. So we don't need to put 199 because the sequence will automatically add the new value. The name doesn't matter. Can name it last want. We only need to be looking at for the unique constraint, right? The unique constraint for the table is email. So even if we enter the same name, first name and last name, it doesn't matter. So the email address has to be different because so there is a unique constraint on that table. So the email would be whatever. The phone number too is not a unique constraint, so the phone number doesn't matter. Phone number does not matter. And then the next one is the date. The date too doesn't matter. It can be the same date. That's fine. There is one null value somewhere. I think it's commission. Okay, so it's after salary. Okay. So this is the job ID. After job ID, we have salary. Yes, after job ID, we have the salary. After the salary, we have null for commission percentage. After commission percentage, we have the appointment ID, which would be 124. You can just keep it the same. And the department ID would be what are some of the values for the department ID? Let me see one of the value for the department ID. 50. Okay. So by using that, we're going to add one sequence, but I want us to add many at a time. Okay, I need to specify next value for next value, right? I need to specify next value so that it will add to the column, to the table. It will be the next column added. Okay. So I'm going to do the same thing and like 4 times. I'm not sure it has all that space. So the only thing that I want to change here is email, because email is has a unique constraint, right? Okay.
No, thank you.
Okay, now let's run it. Okay. I didn't insert. I didn't put semicolon at the end. Seems like I didn't. Okay, let me check. I didn't. Okay. Semicolon, semicolon. Okay, 4 rows created, right? So the original value was 206. We're expecting to have 207, 208, 209, and 210 because we added 4, right? So let's do the same. Select all from test that order by employee underscore ID. Okay, you see, you were added, right?
Okay. Emerald, so here, how did you know that email was a unique constraint?
Because of this morning. The other one I would have to check. I would need to check because of this morning, basically.
Okay, and by checking, you just test the table?
We'll get there. No, exactly. That's the thing. That's the comparison we wanted to make. When you describe, right? When you describe test that employees, you see that employee ID, first name, last name, email. Wait, actually, no, I didn't use the right example. I'm sorry, guys.
Okay.
It's not the right example. I should have used test that HR that employee because test doesn't have a unique constraint, basically. I should have used HR. HR has a unique constraint.
Question, so why does test not have a unique constraint? So when you copy the table, you don't also copy like the structure?
No, we copy the structure, but we do not copy. Anyway, we will get there. I need to do that as HR. Let me check which user am I connected as system. Okay. One row created, right?
Okay.
Now let me select all from HR that employees. I want you guys to see the difference. And they forgot to order by. Select all from HR that employees. Order by employee underscore ID. Okay. So here it goes, it skipped 210 because in the other table, you know that sequence had 207, 208, 209, 200. It actually was not really the example that I wanted to use for
Wait,
this.
so why did it do that? Did you specify it on the SQL?
No, because that's the name of the sequence, right? The sequence is an object, so it allows it creates.
Okay, it gets from the
for each. Yes. So when the sequence is passed, it will just move on to the next, whether you use it on one table or on another table. You see that we use it on different tables, right? But the values that were added that by using that sequence were skipped. Otherwise, you would have started from 206. You see? Now, I want to use another, this is not the example, let me show you guys. Because here, right, on here, you can see that 206 was duplicated. The employee ID 206 was duplicated. But if it was HR, it would not have been duplicated.
Okay.
Right?
Right.
HR would not have allowed that. HR would have skipped to the next one or would have given you an error. So I want
okay. All right.
That's why I wanted to use HR. So I want to create a sequence to do that with HR. So we are going to, the last one for HR right now is 215. So start with 215, increment by 1, max. And the name cannot be the same, right? The name cannot be the same. Okay, let me give it the same name. The name cannot be the same. It wouldn't go through.
So in this case, does that mean that HR has two unique constraints, like two columns that have unique constraints?
Yeah, a table can have multiple constraints.
Okay.
But can only have one primary key. Right?
And you say for HR, the primary key will be email?
No, the unique constraint is email. The primary key is employee ID, right? We are getting there, Anita, don't worry.
So can the primary key and can it be the same?
What? The primary key
and the unique constraint?
No, they are different.
Okay.
They are different. They cannot be the same.
And then both cannot be duplicated either.
Right.
Okay.
None of them can be duplicated. for unique constraint, for example, you can have null values, right? But for primary key, you can have a null value for primary key.
Okay.
Okay, let me continue. Let me just, you're getting there. It's because there are more things with indexes that would add, but we should finish this by God's grace. So I'm going to change it, the name as well, and the email name. If I put the same email name, you guys will see that it wouldn't go through for HR. But if it was the same for test, it would definitely go through without a problem. So I need to change it. XX, 3X, 4X, 5X. Okay. Now I'm going to insert. Paste. You see?
Okay.
The first one didn't go through. Unique constraint email violated. Okay, so it's an email that I already had before, which is the first one.
Oh yeah, because you just copied.
Oh, I didn't edit that the first one. I didn't edit the first one, you see?
Okay.
So it wouldn't allow me to add it because, okay. Because it already has it. It already has it here, you see? So that's why it wouldn't allow me to unique constraint. Even just from getting an error, right, you know that, okay, that table has unique constraint. So it was not created, but it was kept though. It was kept. So we ended at 215. The 216 was not created. It's kept directly to 217.
Okay. So to solve that, you have to just flash back, or you just, can you enter the values manually?
Yes, you can enter the values manually. Let me go back and select that. Select segment. I want to use select statement. Okay, 2.6, it skipped to 2.11, 2.12, 2.13, 2.14, 2.15, 2.16, 2.17, 2.18, 2.19. So you can see that it was not even going to create the first one in the first place because I think we started with 2.15, but we already had 2.15. So it went on to create the next one, 2.16, 2.17.
Oh,
anyway,
okay.
This is basically what sequences are, right? It allows you to, without knowing which employee it is, right?
Mm-hmm.
You just add a new one without having to. Okay. Now synonyms, right? Now let's go to synonyms.
So question, when you create the sequences, right, can you do, I mean, once you're done with them, can you just drop them?
Yeah, of course, you can.
Okay.
You can drop sequence. You can drop sequence, just drop sequence name, and drop it. Okay. Yes, and the sequence is owned by the user who creates it, right?
Okay.
The user creating is, for example, that one we were connected as
Yes.
sys, so it belongs to sys. If you create a sequence as, okay, you're connected as system.
Okay.
So we're
So
connected as HR, it would be the name of that object would be HR that sequence, the name of the sequence, right?
and you have to grant a privilege for that to other
drop.
users? No, to be able to create their own sequence.
Yes.
Like, okay.
Yes, you need to grant that privilege. Okay. And if you want another user to be able to drop it, you can also grant them the privilege, drop any sequence, right? Or select any sequence.
Okay.
Okay. So this is basically how sequence work. But the issue with sequence is if you got something wrong, you can always go back and do it manually if it didn't go through.
So can you create sequences without including numbers in there?
No.
Okay.
Generic numeric value. So it has to be an integer from 0 to infinity, right?
Okay.
Okay, for indexes, what are indexes?
It's like a, how do they call it?
It's a pointer.
Yeah, pointer, or
it allows you to quickly have access to specific rows, right?
Right.
Yes.
Okay. And synonyms, we come back to indexes later. So that's, for synonyms, for example, it gives an alternative name to an object. There is a student from the morning class, I think Zoe. He asked me that when he tried to select table underscore name from DBA underscore tables, where owner equals OE, he didn't find employees, right? He said he didn't find employees, and he's right, right? The table employees belongs to HR. Those are the table that belong to OE, right?
okay.
And if we did the same thing for HR, we have the tables of HR, right? In OE, we don't have employees, we don't have country, we don't have job, we don't have department. So he was wondering, how could we select the HR, right? That was his question. Should we use customers instead? I said no. OE that employees exist, it's just that it's not a table, it's a synonym, right?
Oh, so that's why the table is they're identical, like when you select them.
Exactly. That's exactly why. So how do you select synonyms? There is the DBA underscore synonyms, and there is the user underscore synonyms. So let me describe DBA underscore synonyms. Okay, you have owners, synonym name, table owner. So let's just select all. Okay, let me do something. I want to resize the DB link, but that DB link is occupying too much space, but it's empty. So format A4. Now let me select all from DBA underscore synonyms, where owner equals OE, right?
Okay.
And I think that's it, actually. Okay. So the owner of the synonym is OE, right?
Right.
The synonym name is countries. So when you select OE.countries, you're not selecting a table, you're selecting a synonym. When you select OE.location, you're not selecting a table, you're selecting a synonym. And the table owner, you can see it's HR. The real name of the table is HR.countries, HR.employees, right? So the synonym here, you can see that they are just synonyms. So OE.employee is a synonym of the table HR.employees. That's why you guys noticed that we had the exact same information in both tables.
All right, so how many tables does OE have? 7? Is it 7 tables?
I think 10.
OE doesn't have a table.
OE has 10 some people are not paying attention. We just select a table name from DBA table where owner equals OE, right? So OE has 10 tables. There they are, customers, promotions, and stuff. And HR has 7, I believe. But you guys can see that here the synonyms are you only have 6 synonyms here. So region is not part of the synonyms, right? OE that region doesn't exist. So only these 6 tables have synonym in the OE schema.
Peter, I have a question.
Sure.
If you select all from DB underscore synonym where owner equal HR, is it going to give you the same thing? Or?
No, let's see.
Of OE.
Where owner equals OE?
No, HR.
HR. No, it won't give you because there are different synonyms. HR might have synonyms as well, or might not. Let's see if HR has synonyms. HR doesn't have synonyms.
Okay.
Right?
Yes.
I don't understand.
So does this mean that in total, OE has access to 16 tables?
The thing is, they are not named tables, but yes, you cannot update by using a synonym.
Okay.
Right? You cannot update. You cannot use a synonym and update, like update synonym, no. You can only update a table. So it only allows you to view the data, to see the data.
Oh, okay. So that's why you asked us to copy it to a different table to be able to update it.
Right.
Okay.
Are we good?
I'm good.
Okay. Okay, database objects. The Oracle database can contain multiple data structures. Each structure should be outlined in the database design so that it can be created during the build stage of database development. You have tables, view, sequences, indexes, and synonyms. Tables can be created at any time, even when the user is using the database. Clearly, you do not need to specify the size of the table. The size is ultimately defined by the amount of space allocated to the database as a whole. It is important, however, to estimate how much space a table will use over time. Table structure can be modified online. Okay, more database objects are available, but not covered in this course. So there are other database objects, and we saw that you can go on SQL Developer and you have all the objects of the database in there. Okay, table names and columns, you guys know. Let's begin with the letter. Must be 1 to 30 characters long, must contain A to Z, $, hashtag, must not duplicate the name of another object owned by the same user, right?
Yeah.
Must not be an Oracle server reserved word, right? Okay. This one you guys know. Create table statement, access another user's table, default option. Okay. You must have create table privilege, right, to create the table. So this is a regular create table SQL statement, create table, schema, table, column, data type, default expression. Okay. So we specify the table name, the column data type, and the column size. We create tables to store data by executing the SQL create table statement. The statement is one of the DDL statements that are a subset of the select statement to create, modify, or remove Oracle database structure. These statements have an immediate effect on the database, and they also record information in the data dictionary. Okay, you know that to create a table, you need to have the create table privilege and the storage area, right?
Right.
Right, okay. In which to create object. That's why you grant, who can give me an example of an error that we've seen before where someone didn't have enough
privilege?
No. For the regarding the space, the storage area. Someone didn't have enough quota, right?
Yeah.
The DBA uses data control DCL statements to grant privilege to users. Okay. Referencing another user's table to create. Okay, that one you guys know that. This is create table, select all from, right? We've seen that. Okay, now let's move on to the default option. Specify a default value for a column during an insert. Okay, default sysdate. For example, here, when you create a table, like you're creating a table high_date, right?
Right.
Every time you add data into that table, it will, remember, it will like use the date when you did it, when you added. So instead of you going and entering the data, right? You can just leave it like that, and the data would be added directly to the table, right? The date would be added. Sysdate is the system date, that is the date of that you have in your server. If you want to see the date, you can just select sysdate from dual, right? May 27, 2020, right? So if you create a table that has the default sysdate, right? This is default. So if you want to add another value, you can insert another value, right? But the default value would allow you to just, every time you enter a new employee, it would put the right date. Are we following?
Yes.
Okay. Okay, when you define a table, you can specify that a column should be given a default value by using the default option. This option prevents null values from entering the columns when a row is inserted without a value for the column, right? The default value can be a literal, an expression, or a SQL function, such as sysdate or user. But the value cannot be the same of another column or pseudonym, such as Nectar or Curval. The default expression must match the data type of the column, of course. In that column, you need to have, you would need to have date, clearly. If you don't have date, of course, it wouldn't work. Okay. Okay, the above statement will insert the null value rather than the default value. The above statement will insert sysdate for the higher date. Excuse me?
No, nothing.
Okay. You see that here, what are the two values for the column? You have ID, the first one, and you have higher date. You see that here we put 45 and then we put null, right? So in the table, you'll have 45 and the other one would be just blank, right? Okay. And in here, you have the ID would be 35. And then even though you didn't put anything, right? It would put, the current date would be inserted. We're good?
So the current date will be inserted after the 35.
Right.
Okay.
Creating tables. Create table, you guys know how to do that. Default sysdate. Describe table, you guys know how to do that. Data types. Okay. What are some of the data type that you guys know that we've seen so far? We should know at least 4.
Dates, backup.
Number.
Date.
date,
Varchar
varchar to car, right? You guys know at least 4. That's good.
No.
Null is not a data type.
Okay.
Null is a constraint. Okay. Varchar to car, number, date, long, club, character, large object, row, binary data, binary, large object, binary file, row ID. So you have different types. You even have timestamp. We'll do that more when we go to like in chapter 7 for flashback. Interval, year to month. Those are the datetime data types. So stored as an interval of years and months, interval day to second stored as interval of days, hours, minutes, and seconds. Okay. So those are just different types of data type. I might bring it to you for the assignment. I'll give you an assignment tomorrow, due on Monday. It's the last one on SQL fundamentals, and then we can move on. Okay. Lesson agenda, overview of indexes, creating, dropping indexes. Okay, indexes. Being brought by that page. Okay. Indexes are database objects, right, that can create to improve the performance of some queries. Indexes can also be created automatically by the server when you create a primary key or unique constraint. Indexes. An index is a schema object, may be used by the Oracle server to speed up the retrieval of rows by using a pointer. Can reduce disk input-output by using a rapid path access method to locate data, right? It allows you to quickly have access to data. It is independent of the table that it indexes, right? And is used and maintained automatically by the Oracle server. Okay, so indexes allow you to directly have access to rows and faster.
Emerald, can you view your indexes on a table?
Yes, you can. I think we could have you view indexes. Yeah, describe DBA underscore tables. You see that you have index name. Let me see. You have index name somewhere. Table name, IoT status. But we should have index name. Let me see. There's something that we described earlier that had it. It's not synonym. I think it's table.
Didn't you select all from DB underscore table? So we can see it.
No. Select all from, you don't want to do that, trust me. You don't want to select all from DB underscore table. But with DB underscore table, you should have an index because most table have indexes.
Okay.
Okay.
So, like for instance,
I know it has it, but I can see it. I cannot see it.
So for instance, if you maybe want to extract data and you want to like pinpoint, get a specific data, you can always export using the index, right?
Excuse me, if you want what?
If you want to export a table or a specific part of a table, you can use the index to pinpoint that, right?
Right. You have DBA table, you also have DBA indexes. Why is it saying Ember? Something is off with that table. With that view. I mean, nothing is off, but the way it.
Well, yeah,
weird.
Yeah, that's weird.
Right?
Yeah.
We don't see the first letters. Why is it doing that? I'll try to. It's not showing. Oh, because of the line size. Let me change it. Okay, that's better. But we do have DBA underscore indexes. It's just that I remember that we just used it. I just saw it not too long ago. I'm pretty sure I just saw it. Maybe I saw it from another view. Okay, anyway, you have DBA underscore indexes as well.
I think it was DB underscore instance. No.
DB underscore instinct?
No, it wasn't that.
No, indexes.
It's indexes.
Okay.
No, this is not the view we're trying to see. We're trying to view another one. Synonym, yes. I think it was DB underscore synonyms. No, it's not. There's something else that we saw. One moment. I know I just saw it. I saw the index where you had option to select. Let me see the objects. Anyway, whatever, let's just continue. It will come back to mine.
Okay.
Let's just continue. Okay. Okay, we're here, creating a table now. We passed that one? Yes.
Yeah.
Indexes. Creating, no, we were before that. Yes. Okay, okay. This is for drop index. You were here, right?
No, in front, up. Yeah.
Okay, we're here.
Yeah.
So it is independent of the table that it indexes. And it's used and maintained automatically by Oracle. Okay. So it allows you to quickly have access to specific rows by using a pointer. Indexes can be created explicitly or automatically, right? When you specify, for example, when a table has a primary key or unique constraint, an index would be automatically created. And the thing with the index is that it allows you to have fast access to a table or to a column, to a row or to a column. For example, here, you see that if you do not have an index, then full table scan will occur. So it would go through, can you imagine a table that has 50,000, or let's use like the example of student 81 today, 5 million columns, right? It can take a while. Like it can really take a while to get to specific data. But if you already have an index pointing to a specific column or to a specific row, you would quickly have access to that information, right? Rather than having to go through the 5 million columns, right? To the 5 million columns and through the 5 million rows, right?
Right.
So in order to avoid a full table scan, we use indexes. An index provides direct and fast access to rows in the table. Its purpose is to reduce the disk input-output by using an index path to locate data quickly. An index is used and maintained automatically by the Oracle server. After an index is created, no direct activity is required by the user. Index are logically and physically independent of the table that they index. This means that they can be created or dropped at any time, right? And have no effect on the table or other indexes. When you drop a table, the corresponding indexes also drop, right? So if you drop a table, the index will drop. So if you truncate a table, that would happen.
It will not be dropped.
Right. Okay. How are index created? They can be created automatically. A unique index is created automatically when you define a primary key or unique constraint in the table definition. Or it can be created manually. User can create non-unique indexes on columns to speed up access to the row. Okay, how are indexes created? Okay, we just talked about it. You can manually create a unique index, but it is recommended that you create a unique constraint which implicitly create a unique index, right? Okay.
So indexes are created from columns, right? Not from rows.
Right. They are creating, but it can allow you to have fast access to specific rows, right? But you want to specify the name of a column, right?
Right.
Because when you look for data, you're not looking for, you're looking for the column and the row, right?
Right.
To have the data. Okay, create an index on one or more columns. Create unique name bitmap index on table column and improve the speed of query access to the last name column in the employees table. So create index emp underscore last underscore name on employees last underscore name. Okay.
So that's to manually create it.
Yes, you can create them manually. You have different types of indexes. You have B3 indexes and you have bitmap indexes. So by default, B3 indexes would be created, but in this case, we have bitmap indexes. Okay, so specify unique to indicate that the value of the column upon which the index is based must be unique. So okay, so when you specify, okay, where is it? Well, the bitmap indexes store the row ID associated with a key value as a bitmap. So I'm waiting for your question.
I'm sorry?
I'm waiting for your question.
On what?
I'm expecting that there is an obvious question here, right?
Wait. Oh, okay. So you mentioned there are two types of indexes.
Right.
You said bitmap and big3 or something?
Like a tree. Type it.
B-trade.
B-tree.
Oh.
And bitmap. Okay. Now bitmap basically allows you to, it's basically used for tables with low cardinality. Do you guys understand cardinality?
No.
Okay.
Like smaller tables that don't have too many columns.
Right. Yeah, exactly. It's for tables that do not have too many columns. Exactly. That have low columns and they don't have a lot of duplicate values. They don't have many unique values, right?
Okay.
So for smaller table, let's just put it like that. For smaller table with less cardinality, right? Meaning with less cardinality, you need, it would be better to use bitmap. But for tables with high cardinality, it would be better to use B-tree indexes, right?
Right.
Okay. Okay, let's move on. Index creation guideline. A column contains a wide range of values. A column contains a wide range of values. Okay, create an index when a column contains a wide range of value. Let's take an example. For example, we saw that bitmap, right, was for tables with low cardinality, right? Meaning when a column that has few values, right? Table that has column with few unique values, right? Hello?
Can you come again, please?
Okay. I said that bitmap were used mainly for table with low cardinality, right? Meaning that table that had columns with few unique values.
Correct.
You see that in the table like HR.employees, how many columns do we have that have unique values?
2.
Hmm?
2.
Exactly. We have two. We have the primary key and we have the constraint, the unique constraint on the email, right?
Yeah.
But you can have tables with even more unique values, right? You can have table with multiple unique constraint, right? You can only have one primary key per table, but you can definitely have multiple unique constraint, right?
Yeah.
Okay. So
I have a question.
Sure.
Okay, so you know those tables that we triplicated, we copied from HR and we triplicated. Are those, do they come, are they created with the indexes or do we have to create those?
They are created
with indexes. Okay.
Yes. And you guys better remember bitmap and B-tree because it's not going anywhere as well. And I think in DB1 we talked about it a little bit, right?
Barely.
No.
I know we did a little bit. Don't say we didn't. Okay. A little bit, but not as much. But just remember high cardinality when you have a lot of unique values in columns or in common values, and low cardinality when you don't have many unique values. Okay. So by default, B-tree is used because it's like a tree. It can quickly have access to the different data at the same speed, if I can say it like that, the same space, for different, have access to different rows at the same speed. Okay.
So for instance, the HR table, that will be like it will have a bitmap index, right? Or is it B-tree?
It can have bitmap, B-tree. By default, it's a B-tree that is okay. The table HR, oh, I think I know where I saw it. The table HR has it. It's from DB_tables. Let me see. Join_index. The way it's so long, this is DB underscore table. Let me describe DBA underscore users. No, that's not it. Or let me try no, user underscore tables. And I can't remember.
But no, how about if you do select all from DB underscore table where owner equal HR? Because
No.
Wait, that will just show you the structure, or would that show you the?
No, it will give us all this information that you have here: table name, table space name, cluster. No, we don't want that. It's too much information. Anyway, it's okay. I'll find it. I just remember. Okay. Okay, the table is large and most queries are expected to retrieve with less than 2% to 4% of the row. When not to create an index? When the columns are not often used as condition in the query, the table is small, or most queries are expected to retrieve more than 2% to 4% of the rows in the table is updated frequently, or the index columns are referenced as part of an expression. Index. More is always better. When to create an index, right? When the column contains a wide range of values, when the column contains a large number of null values, one or more columns are frequently used together in a where clause or join clause, or when the table is large and most queries are expected to retrieve less than 2 to 4% of the rows. Remember that if you want to enforce uniqueness, you should define a unique constraint in the table, and a unique index will be automatically created, right?
Okay, so.
Okay, let me just use, instead of, I wanted to find it in a different, from a different data dictionary view, but I'm just going to use DB underscore indexes. But I know this is not the view that I wanted to read it from. But let's just use DB underscore index. Okay, so select table underscore name. Index underscore name. There's index underscore type as well. Yes, index underscore type. You guys cannot see the bottom of my screen.
Yeah, that was I was gonna say.
Index underscore type from DBA underscore indexes, where owner equals HR, and table underscore name equals employees. How many indexes are you expecting to have in that table? How many did you expect to have?
7.
Why?
Because there are 7 columns. Oh, wait, no, never mind. I don't know how many columns, but 1 for each column.
107.
So, are you serious?
No.
You expected to have 1? Come on.
6.
Am I right?
Well, that table has 6, and you never created an index for it, right? So it created 6 indexes for HR employees.
Am I right?
Yes.
So the indexes were created from the column, right?
Right.
Yeah. So I'm sure there are 6 columns in HR.
No, there are 7.
There are 7. So why is
Yes.
it 6?
There is employee ID, there is first name, there is last name. Do you see first name and last name here? No.
Oh, okay.
You only see name, right? There is an index for the names. There's an index for manager ID, for job ID, department ID. You notice that there isn't an index for commission percentage. There isn't an
What?
index for yes.
Why is that?
Depends on the you will understand later.
Okay.
All of those have constraint attached to them, even though they are not unique constraints, right? That they do have constraints.
Okay. And then the type, why is the type not specified here?
The type here is the default, so it's B3.
Okay.
Yes.
So if we if we select the same thing from one of the tables that we created, are we going to see the same thing?
If you what?
If we select table name, index, and
let's do it. Let's try it. We just duplicated and we use, which one did we use?
Test.
Okay, we owner is test. And the table name was employees, right?
Yes.
Right? Even though they are duplicates, we didn't create first that table, right? Test that employee, even though it's a duplicate of HR employees, it has the same structure, it has the same data, it doesn't have the same constraint. The constraints are not duplicated from one table to another. So since that table doesn't have any constraint, that's why it doesn't have the indexes were not automatically
so if we
created.
want, we'll just have to create them ourselves.
Right. Or you can edit, right? You can alter, change the column, right? You can modify a column data type and add primary key. But this is also part of the lesson is coming down. Okay, so we are good with bitmap and B3 indexes and basically indexes. Okay, drop index, index name, and of course you need to be the one that created that index, or the one need to have the privilege, drop any index. Okay. Creating a table, okay. You guys remember when we duplicated that table, that's a tough SQL statement, right?
Yeah.
That's weird.
That is a one SQL?
Yeah, that's one SQL statement. Okay, so that's the SQL statement that was used to create a table HR employees, right?
Okay.
So basically when we copy, right, it would just copy employee number 6. It would skip constraint employee ID primary key. It would skip that.
Okay.
It will skip that part, right? First name, it will just copy first name, but I mean, that one doesn't need. But last name, you can see that it has a constraint as well, right?
Right.
Sorry. And email, you can see that email has a constraint, actually 2. Not known constraint and unique constraint, right?
Right.
So can be no. Phone number, no constraint. Hire date, constraint, can be no, right? Job ID, constraint, can be no. Salary, constraint, cannot be below 0, right? That's the check. That's also a constraint check, right?
Right.
Yeah.
Commission percentage, no constraint. Manager ID, constraint. References, meaning that it's a primary key in another table. So it's a foreign key, right? References means foreign key. It's like foreign key, constraint. Constraint, same, reference, foreign key. So how many constraints do we have here? 1, 2, 3, 4, 5, 6. Wait, I think some of them had both. We have one for last name. We have one for primary key. We have one for employee ID. We have one for last name. We have one for email. We have one for hire date. Okay, let's go back and look at it and compare both. Let's see. And so we can see which one was used. Okay, there it is. Okay, so we have employee ID, that's the first one, right? Primary key, an index was created. We have last name, that's the last one. Not null. We have email. We have email. That one here. So 3. The next one, constraint, is hire date for not null. It wasn't created. For hire date, it doesn't have an index. Unless I'm not seeing right, but hire date doesn't have an index. For job ID, has an index. The constraint here is not null. And salary, check greater than 0. Salary doesn't have an index. And we are going to use DB underscore. Did we use that? DB underscore constraints? No. Okay, we need to use that. Manager ID reference. Manager ID has.
We don't really see what you're looking at.
You don't? Okay,
No,
actually, I'm comparing like what we have here, the constraint that we have, and the index that were created. So actually, I want us to see, to use the view DBA underscore constraint. Constraints. Yes, this is where I got it from. I told you I got it from.
Yeah, I think
underscore indexes, right?
indexes.
So it was from DB underscore constraints.
But you didn't type that before, Amber. You didn't.
No, I
That
didn't
was
type
in the
that.
morning.
This morning. I
Yeah.
started this morning. Yeah. So DB underscore constraint, we have owner, constraint name, constraint type, table name. Okay. Now we are going to compare both tables, HR employees and check that employees and compare the constraints. So you can check the constraint directly. So let's select owner. Constraint name. Constraint type, the type of constraint it is. And I'm only going to put index name. I have the name before we have the name of the index. Okay. Actually, I didn't need to put owner, but it's okay. From DBA underscore, you have DB underscore constraint and you also have user underscore constraints. From DB underscore constraint, where owner equals HR and table underscore name equals employees. And we do the same for the one the test one that we just created. Okay. You can see that, wait, something is weird. You see that?
What?
The indexes are not, the other index names are not displayed here. Do you guys see that? So because they were those other indexes, right?
Yeah.
They were created independently from the constraints, right? It's a table, right? It's RDBMS. Okay. So here we have for owner HR, the constraint names. Okay, we have P, U, C, 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 R, R. What's P for? And you can actually name
primary key.
Right, primary key.
Unique
The
constraint.
U for unique constraint,
Check.
right?
Check.
Email. What's the C for?
Check.
Check. Oh, you guys are so smart, so proud. Yes, the C is for check, right? What does check mean again? What's the check for? It has to check a specific condition, right? For
Like
example, the
it's
salary cannot be below 0, clearly. Salary cannot be paid minus 500, right? Doesn't make sense. So this is for check, right?
Right.
Yeah.
All of these are for check, salary check, last name check. Now, what are the other three? R.
Reference.
Reference, right? And what's the reference? Remember, department, how many they are? Guys, remember, reference. Reference.
It's a reference for primary key from another table.
Exactly. Primary keys from another table. Here you have manager underscore manager's table. The primary key of the manager table is, I think you have management table or something like that, right? Yes. And we have the jobs table. We have the department table. Yes.
You said the reference does what?
Excuse me?
You said the reference does what?
That's what I'm going to explain so it makes more sense. That's what I'm doing right now. So select table underscore name from where owner equals HR, right? Okay, so you can see all the tables of HR, and you see that here we have three unique foreign keys. They are all foreign keys. Employee department is a foreign key, right?
Mm-hmm.
Job is a foreign key. Manager is a foreign key, right? Jobs underscore ID is the primary key of the table jobs, right?
Okay.
DPT, department underscore ID, is the primary key of the table departments. Now, manager ID is the primary key of which one?
That table might be somewhere.
No, it has to belong to HR as well. Maybe not. Let me check.
Because HR has 7 tables.
Let's see. How many we have here? 1, 2, 3, 4.
10.
We have 10.
10.
All right. So it might be coming from. No. It doesn't have to do with the tables. No, these are the columns. HR does have 10 columns.
Okay.
I said it before.
You didn't.
I did.
Employee ID.
Yeah.
So that one is employee ID is the primary key as well. Maybe it's from another table, another schema. I know it's not jobs. I know it's not departments. I know it's not employees. Is it regions? No, it can be region. Locations. No. Country. So it might be from another because here it says foreign key. It's a foreign key. It's underscore FK, foreign key of another table.
In department we have manager underscore ID, right?
In departments?
Yes, ma'am.
Yes, but it's not a primary key in departments. if I describe HR, that department, yeah, we have a manager underscore ID, but you can see that the primary key is department underscore ID. So manager underscore ID is the primary key of another table. Maybe location. Let's try. No, I think we already tried location. Why we didn't try? Countries.
Country.
I don't think it's country. HR that countries. Is it country or countries?
Countries.
No,
No.
IE.
Countries. Plural.
Okay, plural. Okay. No, it's not. It's not country. Jobs and region. It can be region. I know it's for region is region underscore ID. So I can find it. But it's a foreign key definitely of another table. Okay. Maybe it's in Scott. But that
Can we
wouldn't
check?
Huh?
Can we check Scott? Let's see.
You guys like Oracle, eh? Okay, let me check.
Or, I mean, if you check, yeah, if you check the constraint for, or should I say not the constraint, the reference for Scott, it's going to show you the owner of the table and, you know, who has, does it give you the information or no?
Yeah, actually, we can actually add more for this one, the foreign key, view related. You can use like view related. But manager ID, we don't have. I thought HR had. Anyway, we need to find that table. We'll find that table later. But it's a primary key in another table, definitely. So foreign key, that's for R. Okay. Or unless manager ID might be a composite key in another table. In one of the table, it might be a composite key. But anyway, let's just move on.
We will look at it.
Hmm?
We will look at it as well.
Yeah, yeah, I'll look at it too. I'll find a department table. That manager. It's manager, right?
Yes, manager.
It's manager. Where it's coming from. Okay. Okay. So this is what was used to create HR.employees. Create index with the create table statement. You guys know that. Okay, you guys don't know that. Okay, let's go.
No, we don't.
Create table, new underscore, right? The name of the table, employee ID number. And you can see that when you specify the name of the primary key using index, you specify the name of the index. But you don't have to do that because when you have an index, when you have a primary key, an index is automatically created. Right. Select index underscore name, table underscore name from user underscore indexes where table underscore name equals new underscore EMP. Create table underscore EMP. Okay, this is how you create indexes. You just let it follows the primary key or the constraint from a specified index by using index. Okay. Creating a table using a subquery, that one you guys know. I'm not worried about that. Create table.
Please, can you go up to create index? Does it like specify what type of index?
No, it doesn't. It's not specified. Since it's not specified, it will create a bit-tree index. If you specify bitmap, right, it will create a bitmap index.
Okay.
Creating a table using a subquery. You guys know that create table as select all from, right? So
right.
If you don't know that, I'm not stopping anyway. Okay. Creating a table using a subquery. Create table as blah blah from where? You know that. Alter table read only. Okay. Use the alter table statement to add a new column, to add a new column, to modify an existing column definition, define a default value for the new column, to drop a column, to rename a column, to change table to read only status, right? Okay, alter table statement. After you create a table, you may need to change the table structure for any of the following reasons. You omitted a column, your column definition or its name needs to be changed. You need to remove columns. You want to put the table into the read-only mode. You can do this by using the alter table statement. Right? Okay, so you can alter a table. You can alter table to add a column. You can alter table to modify a column. And you can alter table to drop a column. So you see, for example, we can change that table we created, test that employees, by modifying a column and adding constraint, right?
Right.
We wouldn't be able to do all the duplication anymore. Okay, alter table, drop, modify. So I'll send you guys the assignment maybe tomorrow or maybe Friday, I'm not sure. But I'll definitely send it so that you guys can practice, because the assignment doesn't let you modify, use the modified. Only allows you to, I think, move data from one table space to another. So that's all you'll be using. Okay, modify, drop. Okay, alter table, add a column. Alter table, modify, dropping a column. Alter table, drop column. Okay. Okay. We don't need tables. You can use the alter table syntax to put a table in read-only mode so everybody can just read it, but not drop it or not manipulate it, update it, right? So it prevents DDL or DML changes during the table maintenance. Put the table back into read and write mode. So alter table, read only, alter table, read write, right? So you have read only and read write.
Okay.
And okay. Okay. Send agenda, drop table. Drop table is a very easy. You just drop table, table name. And you can drop a table. Oh yeah, also for read only, a table space can also be in read only, right? Not just a table. Table space as well can be read only. Okay. Okay, drop table purge. You drop the table and you purge it. You know that every time you drop a table, it's not gone forever, right? It goes into the recycle bin and it stays there until it's automatically flushed. with it's automatically flushed.
Okay. So purge will be used to just delete it from the recycle bin too.
Exactly. It would permanently remove it. The only way for you to recover that table would be to use a backup. Literally, use a backup.
Okay, Emma, because
No flashback?
No.
Okay.
Emma, I was kind of curious because I know in Oracle we don't delete anything, like literally can't delete anything. That's if I'm right.
How do you mean you cannot delete anything?
No, I'm saying like, you know, of course, like when we say delete, you can delete something, it would delete logically, but it won't go out completely.
Yeah.
Yeah.
Yes. So, Oracle database provides a feature for dropping tables. When you drop a table, the database does not immediately release the space associated with the table in case you want to bring that table back, right? Rather, the database renames the table and places it in a recycle bin where it can be recovered with a flashback, right? So even if you drop it, you can always recover by using flashback table. If maybe you drop by mistake or whatever reason. But if you know that it's not a mistake and that table is occupying space for no reason, you can just use drop table and include the purge clause. So, right. So you free the recycle bin. If you specify purge and the database does not place the table and its independent object with the recycle bin, so it's gone. Using this clause is equivalent to first dropping the table, then purging it from the recycle bin. The clause saves you one step in the process. It also provides immense security if you want to prevent sensitive materials from appearing in the recycle bin, right? So that's something to do only if you're sure that you really want it gone. You cannot roll back a drop table. We know that. You cannot roll back a truncate, and you clearly cannot roll back a drop table with the purge clause. And you cannot recover the table if you drop it with the purge clause. The feature was not available in earlier release. Okay, this feature, so purge. You can use constraints to do the following. Oh, okay, question. You can use the constraint to do the following. What's the answer? 1, 2, or 4, or 3? First, you can use constraint to do the following. Can you use constraint to enforce rules on the data in a table whenever a row is inserted, updated, or deleted?
Yes.
Right. Can you prevent the deletion of a table?
No.
If you put it on read only or offline, are we gonna be able to delete it?
Right. Good, Koji. Exactly. Read on. The thing is, it doesn't specify here that read only is a constraint, right?
Mm-hmm.
But read only is a constraint. When your table, when the table is in read only mode, that's actually key. Even this morning we were like, but yeah, read only is a constraint. When your table is in read only mode, you cannot delete anything. You cannot make changes. So it prevents you from deleting data in that table, right? So it prevents the deletion of a table, right? The key element here is to know that read-only is a constraint, right? Because it was not specified. So yeah, exactly. It's not specified, but it is. Okay. Prevent the creation of a table, yes or no?
No, I'm not sure.
No.
No.
Why no? Can different tables have the same primary key?
Yes.
Yes. Are you sure?
I don't think so.
You think so?
I don't think so.
Why don't you think
I
so?
think so. Because the primary key is just for the table.
No, Emma, I don't think so. Two tables cannot have the same primary key.
Uh-huh.
Yeah, it makes sense, right?
Right.
But look at it here. Let me show you. Let me show you something. This is job underscore history, right? What's the primary key here?
Job underscore ID.
No.
Employee.
Oh, employee underscore ID, yeah.
Yes. And is the primary key in?
Employee.
Exactly. So you can have it. I know it doesn't really, it might feel like it's related because they both belong to the same schema, so they may not have the same primary key, right? But they can have the same primary key.
Yeah, because it's like different tables. It's not the same table.
Yes. So, and 4, prevent the creation of data in a table.
Yeah,
Yes.
definitely.
Yes, definitely. 1 and 4, definitely. 2, yes.
Maybe.
Some maybe it's yes, because read only is right? Read only mode. Okay. So we are good for today. Let me show you.
Emma, I have a quick question, please.
Sure.
So I'm kind of confused. What's the difference between dropping a table and truncating a table?
What's the difference between?
Like you want to drop the entire table and you truncate a table. What's the difference?
Are you kidding me? We explained it last class.
Maybe,
okay, fine.
Maybe I didn't catch it.
No, you were clearly here because you were making comments. Anyway, the difference between both is that when you drop it, right? It goes into the recycled bin. It's dropped. The only way for you to recover it is to use flashback table. But when you truncate it, you drop the table, right? You drop the index also are dropped, but it recreates the table.
But if we create a table?
It recreates the table.
Oh, like an empty
table? It changes the structure of the table by removing, excuse me?
It will create like an empty table?
No. Yes, actually, yes. It will create an empty table. A table with no data inside. Exactly.
Okay, now I get it. Okay, cool.
Okay. So I was expecting you to ask the difference between drop table and delete table and drop, not and truncate, not drop and delete, then truncate. They are clearly different. Okay, so this is the assignment. Create 4 table spaces, demonstrate development, what testing, production. Move all the tables in the demo schema to demonstrate table space. Move all tables in the dev schema to the development table space. Move all tables in the quad schema to the quad testing table space. Move all tables in prod schema to production table space. Add a column called SSN with type number 6 to the employees table in the dev schema. So this would be your assignment. Any question?
Right? There's no assignment to.
No, you guys don't need to do that one. You need to do that. But I'll send you a special assignment to.
Oh, really?
Close SQL fundamental. Is the last SQL fundamental you're doing, right?
Mm-hmm. Please don't make it too difficult.
Come on, you can handle it. How do you don't make it?
Does it include all the other classes, or is just this class? Is it inclusive of all the other classes?
What do you mean?
SQL fundamental, chapter 1, 2, 3. Oh.
No. I will only add for chapter 4. That's it. Okay. I mean, come on, you guys did a lot already. I'm not a monster. Okay. So I can show you how to move table into a different schema, or you guys just want to figure it out? You want to figure it out? Okay, good.
So move tables to a different schema.
Yes. Move all tables in the demo schema to demonstrate table space. So you change the table space. You move them to a different table space.
Yeah, you sure.
Just select all now. Or you move each table.
You move all the tables.
At least this time is not one sequel.
Right. Each question is one at a time.
No, she didn't precise.
I know it's one SQL statement. It's move. So you just use the move command to move them to each different. I mean, that's easy though. That assignment is easy. You just create 4 table space. That's the big job. That's all. And then you move all the tables. That's something that people like Anita, Mary, you guys will do that in 5 minutes. These ones, right? So I have to add, right? Okay.
Sure.
You see, she said sure. Okay. Okay, so I think we're good for today.
Okay, thank you. Have a
Welcome.
good weekend.
Thank you too.
Thank you too. Have a good night.